The universe is supposed to look the same in every direction, no special spots, no preferred sides. But everywhere we point our telescopes, we find patterns that shouldn't exist, alignments that mock our models, structures too big for physics to allow. And the uncomfortable truth isn't that we can't explain them. It's that we might not be smart enough yet to understand what they mean. Number 1. The cold spot. Imagine the oldest photograph ever taken. Not of a person, not of a place, of everything. The cosmic microwave background is the afterglow of the Big Bang itself, light released when the universe was only 380,000 years old. It fills the entire sky. And it's almost perfectly uniform. Almost. Because in the direction of the constellation Eridanus, there's a patch that's wrong. A region about 20 times the width of the full moon that's colder than it should be. Now, colder here means about 70 millionths of a degree below average. At some points, 140 millionths of a degree. You'd never feel it. But the typical fluctuation in this ancient light is only 18 millionths of a degree. This cold spot is nearly 8 times that. So something left a mark on the oldest light in the universe, and you'd think with all our telescopes and satellites and supercomputers we'd know what. We don't. The leading idea is a super void. A region of space up to 1 billion light years across with almost nothing in it. If you're a photon traveling through a void like that, you lose energy, you come out a little colder. And there does seem to be a massive void in that direction. But here's the problem. When you run the math, the void only explains about 20% of the cold. Something else is responsible for the rest, and nobody knows what. Now that's the established science. What comes next is not. One physicist proposed that the cold spot is a bruise. That before inflation blew our universe up like a balloon, we collided with another universe, and the impact left a scar on our sky. A cosmic wound from a place we can never see or reach. That's speculative, unproven. But the cold spot is real. The Planck satellite confirmed it in 2013. It's not a glitch, it's not noise. It's a feature of the oldest light in existence, and 80% of it has no explanation. Something touched the universe when it was a baby. And whatever it was, left a mark that's still there, 13.8 billion years later. And that mark, it sits right next to something even stranger. Number 2. The axis of evil. Stay on that map of the oldest light, zoom out, way out. You're looking at the entire sky now, and you're looking at the largest temperature patterns in the cosmic microwave background. At this scale, the hot and cold regions should be random, like static on a screen. No direction should be special. But in 2003, scientists analyzed data from NASA's WMAP satellite and found that the biggest patterns in the CMB aren't random at all. They're aligned. The two largest modes of temperature variation, the quadrupole and the octopole, line up along a single axis. A preferred direction stretching across the entire observable universe, pointing roughly toward the constellation Virgo. That's already a problem. The cosmological principle, the foundational rule of modern cosmology, says the universe has no preferred directions, no front, no back, no up or down. And yet the oldest light in existence seems to disagree, but it gets worse. That axis also aligns with the plane of our solar system, the disk where Earth and Mars and Jupiter all orbit. The CMB is slightly colder above the solar system, slightly warmer below it, as if the orbital plane of a few rocky and gaseous planets around an unremarkable star has some kind of connection to the structure of the entire cosmos. Two physicists named it the axis of evil in 2005 because of what it implies. If this alignment is real, and not some artifact of how we process the data, then either the universe has a preferred direction, which it shouldn't, or our little solar system is somehow cosmically significant, which it really shouldn't be. The European Space Agency's Planck satellite was supposed to settle this. It was more precise than WMAP, better instruments, cleaner data. The anomaly didn't go away. When you include higher order patterns up to the 5th mode, isotropy, the idea that the universe looks the same in all directions, is rejected at over 99.9% confidence. Nobody has a mechanism for this, no theory predicted it, no model explains it. The universe's baby photo has a stripe through it that lines up with your backyard, and the best cosmologists in the world have been staring at it for over 20 years with no answer. So far, the oldest light looks wrong, but maybe that's just the background. Maybe the actual stuff out there, the galaxies, the matter, maybe that all makes sense. It doesn't. Number 3, structures. Too big to exist. Here's a rule. The universe on the largest scales should look the same everywhere. Galaxy here, void there, cluster over there, but average out over about 1.2 billion light years, everything should blur into uniformity, like zooming out on static until the screen looks gray. Above that scale, there should be no structures, no patterns, just smoothness. In 221, a doctoral student named Alexia Lopez was studying light from distant quasars and found something that shouldn't be there. A crescent-shaped arrangement of galaxies, clusters, gas, and dust stretching 3.3 billion light-years across, 1/15 the radius of the entire observable universe. She called it the giant arc. Then, in 2024, using the same technique, she found another one. A near-perfect ring of galaxies, 1.3 billion light-years in diameter with a circumference of about 4 billion light-years. The Big Ring. If you could see it with your naked eye, it would span 15 full moons across the night sky. Both of these structures are in the same region of the sky. Both are about 9.2 billion light-years from Earth. Both existed when the universe was half its current age. And as of early 2026, a thin filament was found arcing above the Big Ring that appears to connect it to the giant arc. They might be one structure. Now, some astrophysicists argue these aren't really structures at all, that they're random clusters of galaxies our brains are connecting like constellations, dots that happen to line up from our angle. The community is genuinely split on this. But Lopez ran statistical tests, and at least one surpassed the gold standard for significance. And here's the thing, it's not just one impossible structure. There are at least 7 of them now cataloged, some detected through quasar groupings, some through gamma-ray bursts. One of them, the Hercules Corona Borealis Great Wall, spans 10 billion light-years. If even one of these is real, the cosmological principle is in trouble. If several of them are, it might be broken, and one of the proposed explanations is wild enough to mention: cosmic strings, hypothetical wrinkles in space-time from the very first moments after the Big Bang, thinner than a proton, possibly stretching billions of light-years. We've never detected one, but if they exist, they could warp how matter clusters on the largest scales. The universe was supposed to be smooth. It keeps showing us shapes, and those shapes aren't even the most unsettling pattern, because the universe can't even agree on how fast it's growing. Number 4, the Hubble tension. There are 2 ways to measure how fast the universe is expanding. Both are reliable, both have been checked and rechecked, and they give different answers. Method 1. Look at the cosmic microwave background. Use your best model of cosmology to extrapolate how fast the universe should be expanding today based on what it looked like 13.8 billion years ago. You get 67.4 kilometers per second per megaparsec. That's the prediction. Method 2. Look at the nearby universe. Find stars called Cepheids that pulse at rates tied to their brightness. Use them to calibrate the distance to exploding stars called Type 1a supernovae. Measure how fast those supernovae are moving away from us. You get 73 kilometers per second per megaparsec. That's the observation. The difference is about 9%. That might not sound like much, but it's like 2 surveyors measuring the same continent and disagreeing by the width of France. And after more than a decade of checking, the gap hasn't closed, it's gotten more solid. The statistical significance is now above 5 sigma, the threshold physicists use to say something is definitely real. In 2024, the James Webb Space Telescope, the most powerful space observatory ever built, confirmed that the local measurements aren't wrong. The nearby universe really does appear to be expanding faster than the early universe says it should be. Then in December 2025, a third completely independent method using gravitational lensing, where a galaxy bends light from a more distant quasar, and scientists measure the time delay between the warped images, got 72.1, siding with the local number. Citing, one cosmologist at the Keck Observatory said it plainly: "Cosmology as we know it may be broken, and it gets stranger. There's a wild possibility that we live inside a 2 billion light-year wide void, a region about 20% emptier than average called the KBC void. If true, local galaxies would appear to recede faster because there's less gravity pulling them back. Our measurements would be skewed because we're inside the bubble. Data presented in 2025 found a void model 100 million times more likely than no void at all, but others found no evidence for it. Still contested, meanwhile, a separate survey of 15 million galaxies found that dark energy, the mysterious force driving the expansion, might be weakening. If the standard model is right, there's only a 1 in 30,000 chance of getting that result. One physicist even calculated that if the cosmological constant is actually negative, the universe could stop expanding and collapse in about 20 billion years. Two numbers. Both correct, both impossible together. And the resolution might rewrite everything we think we know about the fate of the cosmos. But the Hubble tension is just numbers that don't match. The next pattern is more personal. Because it's the reason you exist, and it shouldn't be. Number 5, why anything exists at all. The Big Bang produced matter and antimatter in exactly equal amounts. That's not a guess. That's what every equation, every particle accelerator, every experiment we've ever run says should happen. Equal and opposite. A particle and its antiparticle for every single interaction. And when matter meets antimatter, they annihilate. Completely. Both disappear, replaced by pure energy. Photons, light, nothing solid left. So here's the problem. If the Big Bang created equal matter and antimatter, and if they all found each other and annihilated, the universe should be nothing but a bath of light. No atoms, no stars, no planets, no you. Just photons drifting through an empty cosmos forever. That didn't happen. And the reason it didn't happen comes down to the tiniest imbalance imaginable. For every billion matter-antimatter pairs that annihilated, one single extra particle of matter survived. 1 in a billion. That leftover is everything. Every galaxy, every star, every grain of sand, every cell in your body. You're a rounding error in an apocalypse. And the ash from those annihilations, it's still here. The cosmic microwave background contains about 1.6 billion photons for every proton in the universe today. That's the scar. That's the receipt from the destruction of almost everything that ever existed. In 2025, scientists at CERN found a new piece of this puzzle. For the first time ever, they detected a matter-antimatter asymmetry in baryons, the kind of particles that protons and neutrons are made of. Over 80,000 decays measured across 2 runs of the Large Hadron Collider. The beauty baryon, a particle containing a heavy bottom quark, decayed about 2.5% more often than its antimatter counterpart. Published in Nature. But here's the devastating part. The asymmetry they measured is many orders of magnitude too small to explain why you're here. The known laws of physics produce barely a whisper of imbalance. Something unknown, some process we've never detected, tipped the scales in the first fraction of a second after the Big Bang. And we have zero idea what it was. CERN's own analogy for this is perfect. Imagine spinning a billion coins. Half should land heads, half should land tails. Now imagine some invisible force rolled through and nudged every coin just slightly toward heads. That nudge is why the universe has stuff in it instead of just light. And we've never found the force. We've never even seen its shadow. Everything you've ever touched, everyone you've ever loved, every thought your brain has ever had exists because of a process that physics cannot explain. And that's not the last way the universe breaks its own rules. Number 6. The universe is lopsided. The cosmic microwave background has a feature called the dipole. One side of the sky is slightly hotter than the other, by about 1 part in 1,000. The explanation has always been simple. The Milky Way is moving through space at about 370 kilometers per second toward the constellation Virgo. That motion creates a Doppler shift. The direction you're moving toward looks hotter. The direction you're moving away from looks colder. Case closed. Except it isn't. If our motion through space is what causes the CMB dipole, then the distribution of galaxies and quasars across the sky should show a matching lopsidedness. Same direction, same magnitude. A consistent picture of one galaxy moving through an otherwise uniform cosmos. In December 2025, a team published their findings in one of the most prestigious physics journals in the world. Using radio telescopes and infrared satellites, two completely different types of instruments, they measured the matter dipole. The lopsidedness in how stuff is actually distributed across the universe. It's 2 to 5 times stronger than the CMB predicts. That means either we're moving way faster than the CMB says we are, or the universe itself is inherently lopsided in a way that violates the most basic assumption in cosmology, and the evidence keeps stacking. A separate study of 1.3 million quasars found our implied velocity to be about 1,700 kilometers per second, almost 5 times what the CMB says. Another team using JWST found that galaxies spinning in one direction outnumber galaxies spinning the other direction by about 50% in deep fields. And that asymmetry gets worse the deeper you look. Someone even found a filament of galaxies 49 million light years long that's coherently rotating like a cosmic flywheel. The cosmological principle, the idea that the universe looks the same in all directions, is the foundation of modern cosmology. And it appears to be wrong, not in some exotic edge case, in the most straightforward test you can run. Look at how matter is spread across the sky, compare it to what the CMB predicts. They don't match. One of the lead researchers said the cosmic dipole anomaly has established itself as a major challenge to the standard cosmological model, even if the astronomical community has chosen to largely ignore it. 6 patterns, all unexplained. Each one a crack in a different wall of the building we call modern cosmology, the cold spot, the axis, the impossible structures, the speed that doesn't match, the leftover from an annihilation that should have been total, the lopsided sky, but the 7th one isn't a crack, it's a mirror. Number 7. The cosmic web looks like a brain. Galaxies aren't scattered randomly through the universe, they're connected, arranged along vast filaments of dark matter and gas, hundreds of millions of light years long, linking galaxy clusters at the intersections. Between the filaments, enormous voids where almost nothing exists. The whole thing looks like a web. We call it exactly that, the cosmic web, the largest structure in the observable universe. Now hold that picture in your mind and look at this one, the human brain. Billions of neurons connected by axons and dendrites, forming an intricate web of pathways. Between the pathways, gaps. At the intersections, dense clusters of activity. In 2020, an astrophysicist named Franco Vazza and a neurosurgeon named Alberto Faletti did something nobody had done before. They ran a direct quantitative comparison between the two. Not a vague metaphor. Actual math. The observable universe contains somewhere between 100 and 200 billion galaxies. Your brain contains 69 to 86 billion neurons. Same order of magnitude. Both systems are about 75% passive material. In the brain, it's water. In the universe, it's dark energy. They measured the spectral density, which is basically a way of describing how structure fluctuates at different sizes, and found that the cerebellum's neural network at scales from 1 micrometer to 1/10 of a millimeter follows the same mathematical curve as the cosmic web at scales from 5 million to 500 million light years. Not similar. The same. Both networks are not fractal, which is unusual because most complex natural systems are. Instead, both are what the researchers called scale-dependent self-organized structures. The memory capacity of the cosmic web is estimated at 1 to 10 petabytes. The human brain, about 2.5 petabytes. And then there's the slime mold. In a separate study, scientists took the growth pattern of a brainless single-celled slime mold called Physarum polycephalum, the kind of thing that you'd find on a rotting log, and built a computer algorithm based on how it searches for food. They fed the algorithm the positions of 37,000 galaxies, and it mapped the cosmic web. A brainless organism's feeding strategy reproduces the largest structure in the universe. The lead researcher said the underlying processes are different, but they produce mathematical structures that are analogous. The difference in physical scale between a neuron and a galaxy filament is 10 to the 27th power. That's a 1 followed by 27 zeros, and the math is the same. Gravity, neural chemistry, and slime mold. Nutrient seeking have absolutely nothing in common. Different forces, different materials, different everything. And yet the networks they build are mathematically identical. Nobody has an explanation for this. It's not predicted by any theory. It doesn't fit neatly into any model. It just sits there, quietly, being true. The universe organized itself into a structure that matches the one inside your head. The thing you're using to understand the cosmos has the same architecture as the cosmos itself. We mapped the oldest light in the universe and found it aligned with our backyard. We measured space expanding and got two different answers. We found structures bigger than physics allows, a sky that's lopsided in a way that violates its own rules, and a web of galaxies that mirrors the folds of a human brain. The universe is full of patterns, and the most unsettling part isn't that we can't explain them. It's that they might be trying to tell us something we're not smart enough to hear yet.